In this video, I will share the first part of 27 practices that can help a project team become world-class with respect to quality, schedule, and cost. Look at the list and score where you think you are using the sheet linked below. So what I did is I put together a list of practices, which are my observations over 32 years or so, of where teams perform particularly well. And so I'd like to kind of share them with you and have you kind of score as we go through the list. And then you're going to see where you think you could improve and maybe some recommendations for next steps in your team. So the list starts with the first category, which is deadlines, budget, and project status. So the first practice here is goals are established, clearly defined, and communicated to the organization. So the idea here is that the backlog or the spec or the list of requirements or the goal of the project is clear enough to be able to start work and do work. So here's some examples here. Target D is the opposite of this, where target D is so poorly defined. Actually, there is a target in there somewhere if you look closely, but so poorly defined that it'll be pure guesswork to be able to start the project. Now, if we have lots of money and time on our hands, which we typically do not, then target D could be an option. Just going to go figure out something and go build a killer app and get back with this. So I don't recommend target D because you could really spend a lot of time with the team members guessing what they need to do. And if they guess differently from each other, that could lead to a lot of issues downstream and products being cancelled and delayed. Now, target A, on the other hand, is equally not recommended unless you are lucky to have a very clear spec or a clear list of requirements to work towards. Most teams do not have or not given a crystal clear list of features that they have to then code to and then perform. So if you have target A, then you're lucky, go with it. But typically teams will have target B and target C. Target B is where the project requirements are fairly well known, but they're ambiguous. So build me a reporting system or deal with the radar system or output this data. And you have to really kind of elicit the details of that before you can start. So target B is workable. You can actually understand the concepts of the system and the likely intent, but then you're going to use the project cycles to learn more about the details. And then target C, it basically part of the system is well defined. Maybe it's a legacy system you're going to port to a new platform, and then the other part of the system is poorly defined and has to be elicited and then worked on. So I think target B and target C are good workable states to kind of do a project with, because you can then use the time in the project to elicit, refine, and tweak the requirements definitions. And target D and target A are likely either not likely to occur, or target D would be like a non-starter or not recommended. So number 2, project teams determine what they can accomplish based upon historical effort data, and they constructively negotiate this with the management team, marketing, and customers. So there are really 2 parts of this particular practice. One is to have data and one is to negotiate. We'll take each one separately. The first thing is to have some data. If you are given a deadline, have some data to substantiate or check the deadline against. Like, can we really do this? And if you have no deadline, then have data to then derive the deadline. So the data would be, for example, a breakdown of the requirements as best as you know them from step number 1, a breakdown of the high-level tasks to understand the likely work involved. It may not be a very detailed task breakdown now, but kind of a first picture of the task breakdown. Complexity. So if you have a complexity scale like 0 through 40 or 1 through 40, or high, medium, and low, you can then indicate things that are complex, like 40 is complex, 1 would be not complex. Effort, you could put the likely hours or days required to do the work, in terms of labor days or people days. And then if you had difficulty coming up with a precise number, you could then put in a range. So most teams, and I would myself, put a range in there to basically comprehend the ambiguity in that part of the project. And they're kind of just going to list the assumptions those numbers are based upon. So if we had no deadline whatsoever, we could use the data to then help derive the deadline, and even options. Maybe if you add up all the numbers, it's a bigger number than you wanted to have for the desired or likely deadline they had in mind. and therefore the data could be used to then kind of show options. So requirements 1 through 3 now and 4 through 6 kind of later may be adequate. And if you had a deadline being given to you, then this is a way to assess risk for that deadline. That if the deadline is very aggressive, then you can show that if all the items added up together will be way beyond the deadline, and therefore a sign of failure for the project to accomplish that. And you could use the data then to kind of break up the pieces and say, well, we could have requirements 1 through 3 done by the first part of the deadline, and then come back and do 5 and 6 by the second deadline, and actually use that to negotiate. Now keep in mind that most teams are not particularly skilled at negotiation, and therefore they may have to kind of learn some skills to do this better. I think negotiation in its simplest kind of fashion means helping the customer understand, or the management team understand, what can and cannot be done, and help educate them or guide them to a workable solution, like a workable project definition. So maybe using the data to say, well, if we did everything, then we'll be working 24/7 and make a lot of mistakes, and it could be very risky to kind of miss the whole thing. Or we could basically use our data to say, well, if we did options 1 through 3, maybe that would go quicker and you can get a first version working. And if you want options 5 through 6 kind of done, that could become later. So using the data to kind of break up the pieces into ideas or options for the customer and manager to understand, and use that to kind of help educate them about what is possible. They want to have a success on their hands and not kind of a major failure. So the team has to kind of learn how to collect data, have data, and they kind of use that. Number 3 is risk management. Everyone assesses risk. So risks are prioritized and communicated to management at least monthly. And management focuses on risks, not crisis. Now, risk management is a very straightforward thing to work on for any team in any kind of situation. It basically is collecting together as a team what could go wrong, prioritizing that list, and then mitigating it. And it is a way to keep the team kind of sane and keeping ahead of the game, where they're not surprised by major problems occurring. And then also use that to communicate to management about what could go wrong, so they're kind of aware of that. So this is a very straightforward thing to do. And what it can lead you to is a lot of other options too. Maybe you assess risk about the vendor, or risk about the availability of the team, or risk about the technical software being built, or the hardware stability. All of those risks being assessed and prioritized can lead to some very clever and useful mitigation actions to keep the team sane and on track, and also kind of communicate to the outside world what is going on and how they can help react or help you mitigate the risks. So number 4 is communication is amazing. The project manager or Scrum Master determines what information people need to know and when. Now, in the companies I am referring to here, I would say communication is particularly done well. Whether it's a small team, among the team members, or across many teams working together. Let me give you a rough idea of a scale of how you can kind of grade where you are on that kind of a picture. So what I would call a low process maturity team with respect to communication. A group of individuals is put together. They're called a team. No common goal. Communication is sporadic at best. And the PM or Scrum Master, you can call it whatever you like, whatever name kind of fits your world, performs little or no project management. That is, given a choice of either coding and designing, because they're a techie person, or doing PM skills and they're assigned to that role too, they choose the one most appealing to them, which is kind of coding and designing. They kind of put to one side the PM practices, and therefore they end up with a team like this. So we have a loner, person upset with everything, also a person upset with the situation of the team, clique situation where these two kind of guys get together, but nobody else is allowed to know what they know, and this guy is coding something. So again, a little dysfunctional. Again, they're having kind of fun a little bit, but the likelihood of them actually getting together to build a solution to something and kind of work together on that and achieve success at the end is basically risky. Okay, number 2 here, medium process maturity. I would say a Scrum team is a good example of this. the team is put together. I think it's good. There's a common goal, which could be the release plan or the sprint goal. Again, a good example. And communication is periodic. Could be daily, weekly, bi-weekly. I think it's very good. And the PM or the Scrum Master facilitates. So I think an Agile team, as an example, is a good example of a good team communication, particularly when they do Agile well. And great process maturity. Many teams work together. So basically, there are many teams working together on a particular product, like database, hardware, software, OS, etc. And they have a common group goal. So if this is going to share it, go back to number 1, where we have good requirements and good sharing of the requirements among many team members and many teams. And there's systematic communication within the teams and across teams on those requirements. So there are basically get-togethers where they can look at the requirements, discuss them, debate them, refine them, manage them, change them, whatever. And the team members are on the same page on a regular basis about where we're heading and what has changed. And the PM is proactive, and that means that the person doing the PM or Scrum Master activities is looking ahead about what is coming up to basically make sure the requirements and the goals are well established, they're modified and communicated, and then issues that are going to come up are also tracked to closure. So there's a lot of proactive coordination going on. This PM person has no time anymore to really going to do coding, because that would then allow the other issues to kind of crop up like we saw before. So the next category is deadlines, budget, and project status. The first one here, number 5, teams that have dependencies on each other develop integration points that are managed via an integrated master schedule. Now, what you call this is your choice. There are many ways to reflect this. It could be in Jira, like the blocked and blocking tasks. It could be a particular tag you have labeled on things in a schedule to kind of reflect dependencies. It could be a master schedule like this one over here, very common, where they've looked at the teams and the teams kind of work in monthly increments here, and they determine the major dependencies among the team scheme. Now, this diagram is called a PERT diagram, P-E-R-T. It is a very old-fashioned picture, but the issues are current. So I wouldn't get too upset with names of things. If you don't like the word PERT, you find it offensive because it's old-fashioned, then say it's blocked and blocking, kind of the new way to say it. There are plugins you can have for your 2 different tools that extract this kind of data if you have it labeled in the tool. Whatever format you kind of want to use is just adequate and fine. The idea is that you are looking for the data, the issues, like dependencies here, and having a way to kind of flag them and then track them to closure. And number 6, project teams track their status weekly or monthly and report data to the PM or Scrum Master, and sticky issues are addressed early on. So again, this is a sign of a good PM practice where somebody's actively working on what is going wrong or what could go wrong, risks or issues, and then they are bringing that to light with the team, despite how sticky they actually are or annoying they are, and the issues are worked early on. Now, when I see this kind of break down, is where the sticky issues are so sticky, like after week 1, we know we're going to be missing the deadline. And it's so embarrassing to say we're in trouble after week 1. Nobody mentions to anybody about anything until the last week of the project, and then we have a year delay. So I think a good PM is learning that problems early on are small, much better than bigger problems later on, and they have an ability to bring up to the team and have that kind of resolved early on with the team management. If you share these issues early on, you might be surprised how able your team is to resolve them with you or management, and how much they appreciate that because you actually reported them early when they were small and fixable versus kind of later when they were bigger. Number 7, project teams typically meet deadlines within 5 to 15% of the original budget, unless there's a major scope change. Now, 5 to 15% is a very aggressive number. I would say that is not your initial goal. That's what I see the best in class going to do when they have very well defined practices and they manage their work very, very efficiently. I would say if you're within 20 to 30% at the beginning, that's kind of a good number to aim at. If you can get down to that point, then maybe you look at a bigger, better number like 15%. But when practices are done, like the 27 I'm listing here, and the work is well managed, and that means the change really is a change request, and they're going to re-baseline the schedule within the current scope as defined, then because they are good at estimating, good at risk management, good at finding mistakes and whatever in the projects, then the really good ones can aim at 5 to 15% and kind of hit that. Now, they're not going to be perfect all the time. Nobody's perfect all the time, but really good teams can do that pretty well. So I would say 20 to 30% would be a good initial number. If you're more than that, if you're like 30 to 50% or 80% or 100%, like you have a deadline set for 6 months and you come in a year later, or you have a deadline for a year, you come in 2 years later, or kind of 4 months later, whatever, then you may want to really figure out what is going on and why is the work so inaccurately planned. Now, if you're in a situation where you are maybe 50% or more accuracy, okay, greater than 50%, so maybe you predict a year, you're in 2 years, you come in 2 years, or you predict 6 months, you come in on 1 year. Then you may want to consider what is really going on. Now, there's a few projects here and there they're doing pure research, and they don't know exactly what they're going to find out. There may be a few projects here and there that kind of do that kind of work, and they really are doing research, and that is understandable. For most teams that are doing software or systems that have to be deployed, and there's a deadline, and it's not purely new kind of work, then I think more than 50% would be indicating a problem behind the scenes that could be addressed. It could be mistakes being found late, estimation, risks not being assessed, tasks not being defined as done correctly, teams not communicating, for example. So I would say you want to guess at least in the 20 to 30% range as a good example of accuracy, and learn some of the practices that you could use to uncover kind of why that would be the case. The next category is engineering. So number 8, customers and end users are actively engaged in product definition, both speculative and custom products. Now, customer could be the person buying it with the money, and end user could be the person actually using it when you deploy it to the end user or the population you're giving it to. So I would say both are engaged actively on the project from the beginning. If it's a speculative project, like a brand new one with no customers yet, then you've identified who could be a good source of input for you. Maybe they're a good potential customer to kind of buy it if they like it, but in the meantime, they can give you feedback on that particular thing. I would say all teams I work with are very good about identifying customers and getting them engaged in the flow of the work at the beginning. Now, teams that don't do this are typically sometimes scared of the customer. Like they are really scared of what the customer may say if they talk to them. Like they may critique them, or they may have a problem, or they may not like them. They would make the team kind of feel bad. And these kind of emotional, what could happen, basically causing the team to avoid the customer until the last possible second when we deploy. Then they find out their customers are really mad, okay, like more mad than they were before. So I think every team I've worked with over the years, they're particularly good about identifying who needs it early on and getting their feedback and their input on a regular basis as they go through their projects. So number 9, requirements are prioritized, and the team decides when in the project to address ambiguities. So the idea here is that if you have more requirements than you can do, there is a way you can prioritize them in the project. Not everything is priority number 1, and you can then work with management and customers to figure that out, and then set expectations correctly for what will be delivered when and kind of how. So it could be a simple scale of high, medium, and low. It could be based upon the architecture and what they need first, second, and third, given the current situation of the client, kind of what they're going to need to be more productive, the availability of resources. There are many ways you can prioritize the requirements. And then ambiguities. If you have requirements like my number 1 would suggest that are ambiguous, recognizing which ones are ambiguous, to what extent, And then when in the project, you're going to work on those issues. So there could be a whole category of requirements that have to be really refined and worked on a lot before you can go code them. And therefore, you may decide that there's a particular point in time in the project where you're going to then investigate that before you then do the coding for that part. So I think customers and managers want to see that you know where you stand, and when you will address things, versus them being surprised later on by like an unknown or something that got kind of delayed a long time, and then it becomes a major investigation point and then a major delay in the project. Number 10, high-risk requirements are analyzed and prototyped to determine feasibility and the best approach. So all teams I work with, whether they are Agile or they're waterfall or a hybrid version, they all flag high-risk requirements that may make no sense or may be difficult to do or may be conflicting with other requirements. And they flag those as high risk, and they do an experiment, a mock-up, prototype, simulation to kind of figure that out before they go do it in earnest. They may have come up with a requirement that's a really bad idea, kind of make it use AI or make it export to the cloud. That may be a good idea on paper, but a bad idea in reality. And therefore, they flag that as a high-risk area, and they're going to work on that and come up with a much better solution for them and for the customer downstream. Now, all these requirements we've been discussing have to be stored somewhere, and so the idea is to come up with a location you can use for that purpose. A regular Word document may be adequate. It's not the best idea, but it actually does work pretty well. If you're using a tool like Jira, for example, Jira has a plugin called R4J. Jira is not a requirements tool, it's an action item database, and therefore R4J helps you manage collections of requirements and changes to them. Jammer is a requirements tool, Visio, RegPro, Doors, Top Team, Confluence, and SharePoint. They can also be adapted to manage requirements or lists of things. Again, if you're going to have a lot of requirements and a lot of people accessing them, I would then have you go towards more professional requirements tools like Jammer and RegPro and Doors. But if you have a fairly small team or fairly straightforward requirements, then basically some of the plugins or Confluence and SharePoint can be good for that. If you don't have a big budget for tools, then I think Excel can work fine. You can put Excel into SharePoint or some kind of CM system to manage changes with it, and you can add columns for the details. Basically, you're mimicking what some of the other tools can do for you, but in a more kind of manual system. Now, I do have a web page I keep up to date on a fairly regular basis called The Tools to Consider. Go take a look at that. There are example tools up there and the links to the vendors that provide those tools. Okay. Now, the next category is engineering, and the first one is design. Design is performed in iterations, and lightweight and clear design information is captured in an organized and central location. Now, often teams in software, when they hear the word design, get very put off because they think of design being large document, like a 100-page Word document or PowerPoint that is difficult to read, difficult to write, difficult to review, and just kind of out of date. And I want to just clarify, design means the word design versus the design document. And there are other ways to capture design information in the project. For example, if you need to do design or wants to clarify a design or capture design, a simple picture may be adequate. Okay? This picture here is what's called a context diagram. The middle bit is what we're building as a team, and the outside areas are basically things we have to connect to, and the lines will be the connection points. So a very simple way to capture design information would be a diagram like that. Again, not a big document. In fact, this one occupies a quarter of my PowerPoint slide. We could also put interfaces. They could be listed out, and then data definition. So these three things, the diagram, interfaces, and data definition, could be a very simple one-page or a two-pager that basically captures design information and can be done as we go in an agile, iterative kind of format. Again, it doesn't require to be a large document. So again, keep in mind what you may have seen before is big documents called design, but they don't have to be like that. Number 12, interfaces are carefully designed, communicated, and managed when they change. Again, teams that are proactive and focused on engineering get very good at defining interfaces up front and making sure they are communicated to other teams. It could be an API, it could be an ICD, interface control document, but the idea is that they know there are technical data interfaces between them and other systems, hardware, software, data, and that if they don't define these things up front, it could be a major nightmare trying to put things together downstream. Number 13, early versions of components and groups of components are tested to determine their correctness. Anything high risk is then worked on early to minimize surprise and allow time for recovery. I think Agile lends itself to this one particularly well because you can break up work into pieces and they're going to get early feedback loops on those pieces. Even waterfall teams or hybrid teams can obviously assess risk of these areas and then mitigate them with experiments and testing beforehand to kind of check out their completeness before they then go to the next step downstream. The next category is quality and rework. Number 14, process assurance, tests, and peer reviews are performed throughout the project to quickly find defects. There's no throwing stuff over the wall to see if anyone notices the quality problems. Now, obviously this would be a quicker way to do it for the team because you give you more time to work in parallel as the recipient recognizes what they're going to got and then going to do it again. But here, basically, we're applying these practices here to the life cycle. So in red, we have process assurance. For example, if we're doing Agile, we check the backlog is done correctly. We check planning actually has been done, there are estimates and a project goal or a sprint goal. We check the engineering activities in the sprint are done correctly. There's a demo, retrospectives, requirements exist. And towards the end, we check maybe testing is done before we then deliver. So there's a basic process check to make sure the regular steps, in this case Agile, have been done and not skipped. That would be the first thing we do. Secondly, we then add the peer reviews to it, our verification. This could be peer reviews and testing. So basically in blue here, there could be a peer review of the backlog, a peer review of the coding being done, a peer review of the design. So cleaning up the work early on in the particular step here or the iteration. And then testing and making sure the demo is done and there's a test beforehand. So if you can't do the testing because the hardware doesn't exist, there may be a simulation. So all the blue arrows basically help you find mistakes in the technical work being done either by peer review, code review, or a test. And then the green arrow, validation, the first green arrow could be a checking with the customer. We're about to build this thing for you. Is that the right thing? Kind of like a user validation. And then later on, maybe more system tests that are performed to kind of check things work in the intended environment downstream. So really good teams that have very few mistakes made, they have mistakes but very few, basically do practices in their life cycle to clean up the work early on to have their less mistakes kind of made downstream. So number 15 is related to this. Metrics are analyzed to determine the status of quality. So when we have defects being found, we can count them and then track them to closure and look at trends. So the diagram down here kind of shows an example. This is a team doing software, and when they do different levels of testing, they can basically find the defect counts. They were looking at density here, but you can have either raw count or some other calculation. Basically looking at the number of defects found, if that's even acceptable, and secondly, the trend downwards again. Number 16, final tests are executed to show that the system actually works with the customer's data and situation. Now, all these green arrows here are the validation ones, basically simulation, system test, and acceptance testing. They basically make sure that it doesn't just work on our machine in our lab, but actually will work on the customer's machine in their particular environment also. Now, this is the end of part 1 of the video. We've been through 16 practices so far. Look at your score out of 16. If you've been scoring maybe 10 to 16 practices, then I would say that's a particularly good situation. If you've been scoring maybe 0 through 5, maybe there are some things you can pick out to work on in the project, find particularly useful. If you're kind of scoring between maybe 8 and 10 or 12, then maybe there's a few things you can refine and tweak over time that's going to get better. Thank you for watching the video. Please subscribe to the channel for part 2 of the video. If you have any questions or comments, please put a comment down below in the chat and or send me an email. Thank you.